Go ahead now.
Alright, so there was 60 plants total.
Actually, hang on. Actually, guys, we could. Do you want to do this?
Okay. Yeah, you have to remember to add that little in there.
Oh, so you got it. We're not going to get to do it in class then.
No, I figured out.
No.
You've been replaced. You took forever.
Okay, fair enough. That was. I know you're wondering where that in the world that came from, right?
So there's 60 plants total.
Yes.
And 29 were tall. 30 had green keys. 34 had smooth. 12 has tall and green.
12. Tall and green. Okay.
17 has green and smooth. 5 had all three. And 6 had none.
Six had none.
Yep.
Okay. See, I was going to ask you guys if you like Krispy Kreme, but then it just seemed like a funny time to be asking you that question. But it was.
Why?
No.
It's delicious. There's no funny thing about it.
So if I brought them in, you guys would eat some?
Yes.
Okay.
Who would say no to soda?
Well, I got them for my other class, and then I thought, well, maybe you guys wouldn't want them. I didn't, so I thought I should check first. Yeah, but I'm gonna go buy a box of them with.
Nobody shows up. It's just the two.
Okay. Wish we could get rid of this thing here somehow. So anytime I can, I like to start in the middle. Now, actually, none is. Okay, so we can even go one step further. So we'll put none out here. 6. So I got that one. Green, smooth, and tall. We have 5. Green, smooth, tall. Is that okay, or did you make your diagram a different orientation?
I did tall, green, smooth.
I can change it if it'd be easier. Okay. Tall, green, smooth. Okay, there we go. So we've got that one checked off now. And green and smooth. Let's see. Actually, let's toss in, now that we've got these guys, let's try to get some of the full circles here. So tall is 28. 29, yeah, it is. Okay. Green is 30, so I'll put that one out here. Oh, they even told us smooth is 34. Oh, 60 total, so that would actually go outside here. I got that one checked off. Tall and green is 12, so that's this region right here, right? Okay. Now we can't completely use that one, but then green and smooth is right here, and that's 17. Okay, so that's all the information, right? Okay. Let's see. Yeah, this is one of the unfortunate things with Pearson, is that when they randomly generate problems, they vary a lot. Okay. So yeah, this is quite a bit harder than what I gave you. Okay, so now if this whole thing here is 17 and that's 5, then this is what? 12, okay. And same deal here? 7. Okay, which now actually, if the whole circle is 30, and we know these 3, How many is in this area right here? Agree with 6? Okay. So now we're down to these 3 spots. And with this one, we need to actually assign a variable, okay? Sometimes you don't have to get into this, but we do in this case. And this will be the easiest spot to put it is right there, okay? Because, so the whole circle is 29, right? But I know that there's 7 here and 5 here, right? And so in this area here, it's going to be 29 minus 7 minus 5, which is 17 minus x, right? Okay. This is everything you've done so far? All right. So then same idea here, 34 minus the 12 minus the 5. 17 again. How clever. Okay. And then what we know is that if we add up all of the regions everywhere, it's got to be equal to 60, right? So you're saying you've been doing everything right so far and it just isn't. Okay.
I think I might have forgot 6.
Okay, so let's add these up though. So I have 17 minus x, 7, 6, 5, 12, x, 17 minus x, and 6. To get all the regions? And notice I did not include these. You're okay with that? And I'm just including the actual spaces. Not those, not those. So it looks like x is I end up with a negative x.
What I did wrong is I forgot the 6 on the outside.
Oh, just that one right there, huh?
Yeah.
Okay. Somebody have the sum of these numbers for me?
Equals 70.
70? Okay. And of course what we know is that this then is equal to 60. Right? So I'll subtract my 70. So x is equal to 10. So now we can come back up here and say this is 10. So that makes this 7. And that makes this 7. Okay.
So then they asked how many were tall and smooth.
Tall and smooth would be 15.
Yeah, I just forgot
The 6?
the 6 on the outside.
Yeah, one small thing there.
That was nice to see.
At least it's nice to know your thought process is right.
Yeah, I got all that. The only thing I forgot was to add the 6 in there.
Yeah, no, easy enough to miss that. And again, show me that on your work, on the test, and I can give you still most of the credit. Should I erase it now? Do you guys have any more questions you'd like to talk about in the... How would you describe that problem?
So it's the 2 diagrams equal each other, and it's A intersects.
Should I just be putting some circles on the board here?
Yeah.
Okay. Oh, okay.
Is it? I don't know if it's the same one as mine.
Yeah, mine's is different because it was. But it's A intersects
A union?
Yes, union with C prime, parentheses, and then equals, parentheses, A intersects B, and then, in the union with parentheses, A intersects C prime.
So we're just trying to prove by making a Venn diagram that that's true. Is that right? Okay. So, okay, so let's go. A, B, C.
I get the intersect part, but I don't get the union part, I guess.
Okay.
What's that?
So not C or C prime is going to be everything outside of the C. And where it combined with B. So again, C is everything outside of the. So where does it make it any bigger when I do the union with B here? Does it make the area any bigger? And if so, where?
Yeah, you add the part of C where
Yeah, I'm adding this part right here in, right? So now this here then would be all the green plus this little bit of black. Are we okay with that? All right. And now we want to find the intersection of this with A. So, of course, it intersects, we're being covered by green here. Being covered by green, be covering by black, but I can't include this area right here because it's not been shaded by the black or the green, right? So this area right here, including that funny little right there, that's what we're talking about on the left side, right? So that's when we combine it with that. Are we good?
So the only part that would actually be shaded is the A part, right?
Or would it be?
It's everything I have in red.
Oh, okay.
Is this whole thing, maybe I should do it this way. This whole thing here is what I have in red. Because I took the black shading and the green shading, and I said, where does it overlap, or where does it intersect the A? And it intersects here, but it doesn't intersect right in here. Okay? So then what we want to do is we're going to make the same picture, hopefully, following these instructions here, right? So we'll do it again. Okay, so let's see here. So I guess we could start off with not C. So it's going to be everything outside of C. All right. And then let's go for where it intersects A. So it's going to be, this is where not C intersects A. So it's all this here. So that's, I just drew in that, right? Okay. Now let's go over here and grab intersection of B and A. I'll just do it in one color here. So A and B would overlap right there, right? And so then the final question is we want to combine what's in red with what's in black. And now we're not saying the overlap. We actually want to make them all one big, it's one big thing now, right? So then that's going to be black and red. Almost had enough colors here going. So then the final answer would be this, this, like that. Which, it is the same.
So much easier when you do it.
All I can, I get I can empathize. So. What are you thinking, Anna?
Just working it over in my brain.
Well, I could tell that. And so is there a piece, do you just need a little more time, or is there a piece I can answer a question there?
I don't think so. So C naught, exactly, just tell me what C naught.
So
Age and C.
you're talking about this C naught here?
Yeah, talking about everything else.
Everything that's outside of C, and then we want to know where it overlaps with A.
Right.
So we grab this part.
Mm-hmm.
Okay.
For the first part, why is it like
On the left side here?
in the union with not C prime? Why is it in the middle part there?
Okay.
In the black.
Okay, so we found C was everything outside of C, but then we're essentially adding to it the part of B that wasn't being covered up, that's not being included. So all of this out here, we didn't even need the B part because the not C was already giving us all of this, right?
Yeah.
So, but we increase the area when this says we're going to combine with it any part of all of B. So of course this doesn't change it, but this part of B then actually makes our area bigger.
Okay. So makes area, but why wouldn't you include where C prime goes into B?
Oh, I mean we are.
Well, why wouldn't you shade it?
What I was trying to say was, okay, we already have all of this stuff in green.
Yeah.
That we already have that, and now I'm just adding on this additional part.
Yeah.
So I mean, I could actually go and just kind of combine it like that. Does that clarify that?
Okay. And then you want to know where it just leaves it there?
And then yes. So everywhere we have green, where does that
Oh, okay.
overlap A?
That makes more sense.
Yeah. Okay. Is this helping you?
I think the hard part is we just need to figure it out. Nobody can help us. It's like you just gotta figure it out.
I mean, we're going through these pieces. Are you kind of following each step?
Yeah.
So it makes sense. It's just you're just like, wow, would I be able to do it on my own if I stepped away? Yeah. And it is, and that's why I'd like you to try it, but not kill yourselves. Come in and we'll do it. Okay? You know, obviously when they're easy, that's great, but don't just like spend hours. And you're thinking, but I already did. Well, well, and again, I would prefer to have you go and try everything and then come in and spend, if we need to spend half a class working through the questions you come up with.
Yeah.
Here's my little educational philosophy, okay? Is I can tell you something, but if it's the first time you've heard it, you're not sure what to do with it yet. You don't even know what the questions are, what it means, right? So you just like, what do you do with the information you just heard, right? And the question, a lot of times the answer is, you just lose it, right? So, but then if you can go try the problems, then you start to understand what the questions are. You get, because you did hear a little bit in class, you can get part of the way through. So then when you come back the second go around, now you are primed, ready to roll. Now you know what the questions are. Now if I were to tell you something, you'd know what to do with that something. So in my mind, the learning needs to be, it's more iterative. You just try it, And actually, that's one reason I don't like Pearson. Is because we tend to skip that part. Pearson finally helps you enough so you get the answer, and then you just kind of let it go. Right. Or I would prefer you to take the book and try it and not get the answer, but then you can come in and you're ready to ask good questions. And then if I can help you at that moment, boom, you just know what to do with it. It sticks better.
Yeah.
So.
I think that was really helpful to see it again after
Okay.
I tried to look it up.
Right. Because then I think you kind of know what to do with it the second time. The first time you don't. And part of it's the way I but anyhow. Any more? We're going to try to move into the 7.5. So we will definitely not get... Oh, actually, there was one more problem in 7.4, and maybe we don't need to do it now.
I think it's 7 or 10.
Sorry. My book is 7.
Okay.
Your book is 10.
Okay.
In 10.4, the next problem I was going to do on Wednesday was number 31, where we're grabbing marbles out of a bag. Did you guys get all those? Is there any reason to do that example? Does that mean that nod is like you got it all?
That was 10.3, right?
10.4,
It's due today, right?
no,
10.4 is due on
Monday. But on Wednesday, we went through some of the problems in 10.4.
Okay.
We did some of the examples in there. Do you want to see any more examples out of 10.4? That's the question. So when you're just looking in your book, you see any examples that would be helpful to do? I was thinking that we did some.
We did it.
Yeah. I think the last one I have down we did was 22, I think.
And then there was another one that we just kind of like talked over a little bit.
Yeah. So the next one on the list was I always thought we could do like 31 or something. So I can do that if that would be helpful. Or if you see any others in 10.4 that you might want to do before we move on. Nope. So we're going to try to move into 7.5. Okay. So we will not finish 7.5. 10.5. We will not finish 10.5, but we'll try to get some progress on it. So if you do have your book, I would try to get to that section. I can't even tell you the page. It's such an annoying little feature.
509.
What's that?
509.
509? Okay. So one of the things we talked about on Wednesday was mutually exclusive or not mutually exclusive. So mutually exclusive, if I just looked at it, made a little Venn diagram, was kind of like that. There's no overlap between. This is like grabbing the probability of a black card versus the probability of a red card. Okay. Then we talked about where things are not mutually exclusive. This would be a good example. Would be okay. So here was the probability of red or the probability of black. And then this was saying the probability of, for example, getting a red card or the probability of a face card. Right? And of course the overlap is the idea that some of the face cards are red cards, right? So we had to subtract that overlap. Okay, so we're good with that? So there are two other words that are really easy to mix up, and sometimes they're just very similar. So this would be dependent and independent. So let's see. Let me try to give you an example of dependent. Dependent, in fact, using a card example, would be if I were to say the probability of a red card and then the second one have the probability of a diamond. So what's happening here, you could easily tell me the probability. So what I'm saying is, over here, I only took one card in the first place. Okay? So what's new here is I'm taking two cards, and the probability I start off with here, actually, what's the probability of getting a red card? Yeah, 26 out of 52. Okay, easy enough. But now when I go back to grab another card, the first thing that happens, as you can see right away, I don't have 52 cards anymore, right? Because one has been taken out. Now I have 51 cards. Okay? And now you could ask yourself, well, now how many diamonds? And this is a tricky one. Well, and this one is actually even trickier because this card made, we don't know if it was.
Oh.
Yeah, so this actually adds a new layer of complexity. We're not going to have that particular problem. But you get the issue here, right? The first thing, this second event depends on what happened the first time, right? It changes the denominator, changes how many cards we're selecting from, right? So yeah, actually, I should probably tweak that example a little bit because this brings in a new level of complexity we don't need. Okay. So this is the issue, though, is that the second event, the second thing you're trying to do has been altered by what happened the first time. Okay. And so this is what we mean by conditional probability. Okay. And this is especially the issue is when we have things that are dependent on each other. Okay. Okay. Now, let me show you. There's a series of equations that go with this depending on if it's dependent or independent, okay? So it's almost easier to do this in backwards. If we were to go to, maybe I'll just show you the picture, but, oh, there's no pictures. Do you see, like four pages into that section? You should see that page. The biggest word on the page, hopefully, will be independent events, okay? So if you could find that. And there's a couple. You found that? What? 568? 15, 516. Depends on the left and right page then, probably, right?
Does it say independent events in the middle?
Independent events is in a green box.
Oh, green box.
Okay? So flip one more page. Oh, yeah, that's where it starts.
Oh.
And then the thing
Oh.
yeah. So these equations here vary depending on if we are dependent or independent, okay? So these equations, the first one would be, and I'll explain what some of these mean there. So we have the probability of, I guess I'll use their notation, F given E is equal to the probability of F and, let's see, the probability of F intersect E is equal to the probability of F times probability of E. And it repeats this one here. In contrast, though, if you go back to, so that was the independent ones. If you were to go back like 3 pages, you see the what's called the product rule. But this is for dependent events. So they have the same equation here. They say that probability of the intersection is equal to the probability of F times probability of E given F. And then there's one more. Well, we could start with that. So let me explain what I have up on the board so far, okay? And again, the thing I'm trying to point out to you is this equation and this equation, they're both for the intersection, right? But they're different because one is independent, one is dependent. The things we're doing are different, okay? So let me explain this notation. This says the probability of getting something, but you know how do I say this here? If these are cards, we're going back to our red cards and our face cards. This is the probability of getting a heart, knowing that I picked a red card. If the first card was red, that helps me know that, wow, I've got a better chance of it being a heart. Now, right, if I just tell you, grab a card, what's the probability of it being a heart? You would tell me it's 13 out of 52, right? But the probability is better if you know that the card was a red card, right? So that's what this is saying, is if you know that the first thing that happened was such and such, then it increases the probability of this one happening as well, okay? So that's what, when you see that phrase, that's what we're talking about there with that line through it. You're trying to find the probability of this, but knowing that this has happened already. Now, this may look a little weird to you because we're saying if it's an independent event, it actually doesn't change the probability. In other words, let me give you an example. If we're shaking dice, the fact that I got a 6 last time, the probability of getting a 6 this time doesn't change, right? So we're saying that would be independent. But certainly, going back to our card example, it does. Okay, if I already drew a red card, then when I go to draw another card, it will change things. So that would put me, dependent would be over here like the card example. Okay, so in fact, let me give you one more kind of example of where this comes into play. And I'll give you the answer for this on Monday. Do you guys remember, have you seen this show, Let's Make a Deal? Right, the classic thing, I don't even know if it's still on. Is it? Yeah. It is still on? It was on when I was a little kid. And so it's been, I'm sure, a different guy. But, so one of the classic things would be up on the stage, they'd have 3 doors. And he said, okay, there's a brand new car behind one of the doors, right? And you have to guess. Is it door number 1, door number 2, door number 3, right? At this point, you have no information, so you just randomly pick a door, right? So right now you have a 1 in 3 chance, or the probability is 1 out of 3, okay? And then what he would classically do is he would say, well, he would open up one of the doors, and you might see somebody on a bicycle, or you might see a goat. Should I draw a goat? You know what? It does skip the picture right now. But anyhow, so he would show you. He said, okay, behind door number 3. Okay, let's say you pick door number 1. Okay, so he'll tell you behind door number 3 is something you don't want. Okay, some kind of nothing. He said, now, do you want to change your mind or do you want to stick with your first choice? And what would you do? Or does it matter? What's that?
I'd stick with my first choice.
Stick with your first choice? It works that way when you're doing the quiz, right? Stick with your first choice. Yeah. So interesting enough, and I'll show you the math on Monday. It's better once you know that this door is not it. Okay? It's actually better to switch your choices. When you chose this, you had a 1 out of 3 chance. Okay? Now that you use the new information that it's not here, if you leave it that way, you still have the 1 out of 3 chance. But if you switch, what you really are doing is taking advantage of the fact that you now know that this is not one of the answers. And the probability of you getting the car goes up. just by switching, even though there doesn't seem to be. Okay, and so solving this problem is really part of what we're trying to do here too. Okay. Keep these in mind somehow. Okay, I need to erase them so we have some space. And let's try to do some examples in the book. At least I think that was the next thing I wanted to do. Let's see which are the best ones that we can do in a couple of minutes. Let's kind of do this a little backwards, actually. Might make more sense. Let's try to do number 73. So if you've got a book, go to that. So 73 starts off on the left side, lower, there's a table with lots of information in there. So most of you have that book. Oh, you guys don't, do you? Sorry that...
Okay.
So let's try to do 73, and we'll kind of just work our way backwards a little bit through some of the homework problems. So this has like 4 parts to it. Someone tell me what the first question is, and then you'll need to look in the table for me to get the answer.
Find the probability that a person is a current smoker.
Okay? So just smoker in general, right? Mm-hmm. So now when you look at the table, they break it up into lots of categories, but we want to know just all smokers.
Current smokers, right?
See, was the question current smoker?
Yeah, current smoker.
Okay, and then if you go to the very bottom right-hand corner of the table, it tells you how many total. I can't remember, are these in millions or something, or thousands? But what's the number at the very bottom?
192.
So if you were to do the division there, then we would know the probability of being a current smoker, right? Someone do that for me? Okay. So just reading from the table. Again, we're just taking the part out of the total, right? Okay. And then what's the next part, B?
Find the probability that a person has less than a high school diploma.
And what was that? Now, does everyone see that in the table? Now, and you're getting the total, that's for everybody, not just like somehow tied into the smoker part.
She was going off of current smokers, so total less than 28.68.
Okay, what is that again?
28.68.
0.68. And is everyone okay with that? Because it's sometimes a little tricky about where you're pulling it off the table. Okay, and again, this would be out of our total, right? So, what's the probability of less than high school?
0.1489.
Okay. And then what's C?
Find the probability that a person is a current smoker and has less than a high school diploma. And that's where it would be like 7.9.
Okay, yes, that's right. Now we go to 7.9. And is everyone okay with how this is kind of the intersection thing, right? But we're getting it off of the table empirically, right? Okay. But then what will I divide this by? So it's just the same thing, right?
Yeah.
The 192.64. Okay.
.0410.
0410. Okay. And then part D says
Find the probability that a person is a current smoker, given that the person has less than a high school diploma.
actually, so these are all probabilities. Probability of that. Okay, so now the formula for that, I'm trying to think of which page. If you flip back four pages back, you should find probability. I think that it was E given F, or maybe vice versa, is equal to E intersect F divided by the probability of F. Did I get my E's and F's right? Do you find that equation in the book?
This is the dependent.
Actually, go back, maybe two more even. Just want you to be able to find this in your book. Right there. Does everyone find it in the book? And did I get the E's and F's? It doesn't really matter, but have you got them the same way? Okay. So what we're trying to do is find this, right? We're saying given that we know this, find that. So that's the equation we have to work with. So this is actually the intersection right here, right? That's the E intersect F. So it's right there. We know that answer, 0.0410 divided by the probability of the high school part, right? 0.1489. And can you guys tell me that?
.2754.
Okay. So the conclusion is, okay, so this is the probability of being a current smoker. But what it says is if you had less education, you tend to be, it's more likely you're going to be a smoker. Okay? Now, one more thing that could come out of this. Let's say we did the math here, but this number ended up being the same as this. So this tells us that they are dependent on each other, okay? That smoking and education are linked together, they're dependent. But if we did the math here and this number actually was the same, we'd say that they're independent, that there is no connection between the two. How'd that go? All right. So this is really the essence of the chapter, but the question is going to be asked all kinds of different ways. Okay? So to be truthful, I wouldn't spend a ton of time on this until we can finish talking about it on Monday. Okay? You might, in fact, pick out some of the later problems that are like this. I think you'll get those. But some of the earlier ones, there's going to be several other approaches. We're going to be making these little tree diagrams. And so I haven't had a chance to go over those at all. And that'll be, the first group of problems tends to be that way.
And
So
this stuff is going to be on the test as well?
Yeah.
Okay. So on Pearson, just skip those?
So what I would do on Pearson in 10.5, I would probably start towards the end of the later problems and work your way back a little bit. Because the problems will be kind of this flavor, so at least you kind of know how to do them.
Okay.
But if you get down to the lower problems, they bring in some other stuff that we haven't talked about at all. Ultimately, it comes down to the same idea here, but it'll be hard to pick out. So by all means, finish all the other stuff. And you guys probably deserve a little break, but so just start on some of the later problems. Normally you think of these as being the harder ones, and in this case it's not necessarily so. Okay?
Okay.
All right. So I hope you have a good weekend.